Hello guys, today we are going to work with the Universal Asynchronous Receiver and Transmitter UART. We are going to explore the basic principles and then do some experiments. UART is a serial communication protocol. It transmits bit by bit from one device to the other. It can be set up as duplex, transmitter and receiver, or simplex, just in one direction, as we can see in this picture. UART is located in the USCI channel A in our MSP430 board, and it works with a frame that has a start bit that's 0 and a stop bit that's 1. In between the start and the stop bits, there are 8 bits of data, as it is shown in this picture. Each device has its own clock, so this is an asynchronous communication. It is possible to find frame errors when the data is shifted. That's why it is important that the frame is determined, because UART works in a probabilistic environment. As we can see in this picture, the blue signal is the transmitter's clock, and the receiver has a different clock that's in green, and it has a higher frequency. This happens because we need to use oversampling to reduce the risk of errors in the information. The receiver's oversampling has to be 16 times higher than the transmitter's clock, that to have enough samples for the majority vote. Now we are going to test the first experiment, sending bytes to UART. As we can see in the terminal, the microcontroller is sending through UART the digits from 0 to 9 in an infinite loop. At the same time, the red LED is blinking in the launchpad when the information is transmitted. When number 1 is pressed in the keyboard, the green LED is turned on. And when number 2 is pressed in the keyboard, the green LED is turned off, as we can see in this video. For the second experiment, we are going to send a 16-bit number through UART. In this case, the counter starts at 0 and increases to 65,535. Then it goes back to 0 and continues counting infinite times. We can see that the numbers are in the range of the 60,000s, and when we get to the max number, it goes back to 0 and continues, as it was expected. We are going to send a string through UART. As we can see, the string that I typed is being printed in the PC terminal, and it was sent from the microcontroller to the computer. For our fourth code, we are going to change the configuration to the ACLK clock based on the 32 kHz crystal. We are going to set for a baud rate of 4800 Hz, and we cannot use oversampling. When we try to display the result in the terminal, we see that there is like a lot of garbage coming from the microcontroller. This happens because the baud rate was not correctly configured from the PC side. To fix this, I open the device manager and double-click on ports. I select the MSP application UART1 on COM4. I go to port settings and change the bit per second to 4800. That's going to correspond to the baud rate that we have in the microcontroller. Now I go to Composer Studio. As you can see, the sequence of numbers is being displayed correctly and we have no garbage anymore. Okay guys, I hope that you enjoyed this video and I will see you next time. Keep it going guys.